Hey everybody, Jeff here for CS161B. Today we are going to dive into a construct called a struct. And this is a 2-week module. If you look here, excuse me, you see we have structs part 1 and structs part 2. We're going to cover in this video, call it 2/3 of the chapter for this module, and then there'll be a second video which will cover the rest of that and the next chapter. That's just a good breakdown, kind of what I've walked through the material. So we're going to cover these first two sections here today in this video, and then there'll be another video that's immediately available, and you can watch them at the same time, or you can take time in between, whatever you want to do here. But we talk about what a struct is. It's a method of abstracting, grouping um, types of data together so that you can um, operate on a group of data at the same time. And I don't mean like an array. Like an array is a group of data as well, but it's where you have different values that are all associated with each other in some way, right? A list of zip codes, for example. A struct is different. So, for example, let's take our menu, our meal, our food cart program that we wrote at the beginning of this term. And let's say that I wanted to have you add some information each time you entered a food cart item. Not just the item's name and its price, but maybe its calorie count, its whether it's an appetizer or a dessert or whatever, maybe a Boolean flag, whether it's gluten free or not. And so you have a list of attributes or a list of fields or things associated with this concept of a food item. Now, wouldn't it be nice if you could say, hey, I just want to copy a food item to another spot, or I just want to print out everything for the food item. And for the food item, I want to pull out the calorie count. And so you want to think of this kind of more in an abstract. We're going to use this thing called a struct. And what's cool about a struct is it's very freeform in terms of what you want to put in there. You could put, one integer in there, or you could put a bunch of integers and floating points and strings. It's very flexible there. Okay, so we'll walk through some example here of what we're going to do. Like I said, we're going to start in chapter 13 in the textbook, and we'll start with just these first two sections here. Here's an example of what a struct looks like. And in this example, we've just specified an hour value and a minute value. So kind of as an entity, we can think of this thing as time. And I can have a struct called time. Well, it's called time, hour, minute in this case. But I can have this thing, and if I can think of it as a time data type, and it happens to have an hour piece of it and a minute piece of it. Okay, so I picked a different example for us to run because I think I find it helpful. You can do the examples in the book, but if we walk through we're going to create something from scratch, here's what it might look like. Okay, so we're gonna develop a GPS coordinate structure, right? So a common way to express the GPS coordinates for a location is with 2 decimal values. Okay, so we're going to declare our struct type as GPS coord, and we're going to give it a latitude and a longitude. And they both happen to be double values in this case. So for example, if I give you an example of how that might work, if I go into Google Maps and I type 2 decimal values like this and I hit enter, actually I didn't go into Google Maps, I should go into Google Maps and do the same thing. You see I come up here at the Space Needle in downtown Seattle. Okay, so this number, these are the 2 numbers I typed right here. They got converted into a degree format, right? And you can do the math if you wanted to go back and forth here. We're not going to do that. And the other thing that happened here is you notice that a positive 47 got turned into 47 degrees north. That's because the latitude, if the latitude is a positive number, it's north of the equator. If it's a negative number, it's south of the equator. And the Space Needle is north of the equator. And then my negative 122.34 got turned into positive 122 degrees and change west. And so a negative longitude is on the eastern hemisphere. A positive longitude is on the eastern hemisphere. A negative longitude is on the western hemisphere. So those of you in Portland, your longitude and latitude aren't going to be much different than here, right? The latitude will be a few degrees lower, right? 45 and change, I think. Maybe 45 and change, I think. And because Portland is a little bit closer to the equator than Seattle is, right? Okay, so that's our longitude and latitude, kind of the briefing on that. And so we're going to create this here. And so if I want to declare a variable, that uses this struct, we simply just instead of saying int or float or whatever, we say the struct's name and we name our variable, in this case coordinates 1. I can set my values by doing coordinates 1 dot latitude and set that equal to 40. I need to change my putty to let me use my move my hand muscle memory to the right to use my keypad, and my putty sessions don't like that. 6205 coordinates 1 dot longitude negative 122.3493. Okay, this coordinate pair is for the Space Needle until. So I've set my values of my longitude and my latitude. If I want, I can create another coordinate struct, and I can copy it simply by coordinates 2 equals coordinates 1. I can copy the whole struct. I could also coordinate 2 latitude equals I can print out an individual piece of the struct like that. Okay, so let's see what happens when I try to build this. Okay, so I got an error here. The first error here was the expected semicolon after the struct definition. And I'll fix my typo here while I'm in there. And so I left this off on purpose. If you look here, a struct definition requires a semicolon right there, right? So if you see here, there's a semicolon right there. If you see here, there's a semicolon, and so on. This is an exception to where we use curly braces, right? There's no semicolon after this main, right? And there's no semicolon after your for loops and your while loops and things like that. So, don't forget the trailing semicolon. Oops. So now we should be able to rebuild. And if I run my program, I get my coordinate 2 latitude. And so that showed me that my assignment to coordinates 1 latitude worked, and then my copy to coordinates 2 worked. Okay? All right. Maybe this is not so helpful, and maybe instead I just want to do this. I just want to print out the struct. Doesn't like that. Big, long barfing error here. It basically says that it cannot convert here's the key right here. I can't convert a data of type GPS chord to an unsigned char, which is how cout wants to process things. Cout always will take whatever data and I'll try to turn it into basically a C string to print it out. Okay? There are ways to work this, but instead, typically, you're going to create a function you're going to create your own function to print the data how you want. So let's go ahead and create that. And what you can see I'm doing here is I'm sending my struct as a parameter. So I'm sending coordinates 2 as an input parameter, and my value by, or my parameter by value is being declared here as a GPS coordinate type called chord. I just abbreviated it to chord here. So now what we can do is we can make our print function however we want, right? So maybe I'll say paste this into Google Maps. So here I'm printing out how I want in a format that I can jump and I can just paste it directly into Google Maps. Now we can also make our print statement a little bit more sophisticated. And what we'll do instead here is we'll say if the latitude is less than 0, if it's less than 0, then we're going to print it negative, which means we're going to change the sign. Latitude, degrees south. Otherwise, we print the latitude and we say degrees north. And then we can do the same with the longitude. If the longitude is negative, then we put a negative sign in front of it to remove the negative sign, right? Longitude, I still can't spell it. And that is degrees, what is that? Negative is degrees west. Like I am in the Western Hemisphere, and maybe not all of you, but most of you. Else, longitude, degrees east. Okay, so now I have two ways that I've printed this, and now let's add one more feature to my function here, and let's say and we'll say if method equals method1, else if it's method2, else can imagine different ways. Like we can make this function print in with degrees. We can have it bring up a picture. You could imagine all these things we can do as we get fancier and fancier. Nope, we still need to. Okay, so now we get our kind of verbose directional coordinates if I put a 2 there. Okay, so recapping what we've done so far, right? Because we've really quickly covered 13.1, and we've started to cover 13.2. Again, the textbook is showing you examples where we're covering. Let me see if I can find one real quick here. Yeah, so here where I'm passing a struct called product info into the function called add to stock. Now the second thing we're going to do is we're going to write another function that actually returns the structure as its return value, like what is happening here. Okay, so we'll do that next. Okay, so the way to do that is really no different than, again, instead of setting void or int or char or whatever, we're going to have our function return our struct type. And I'm going to write a function called find the antipode. And I'm going to give it a coordinate structure as an input here. Now, so just like the previous function I wrote, we're going to give this an input here, and we're going to do what's called the finding the antipode. Okay, so I would do my show of hands to see how many of you have heard of an antipode, and maybe one of you would raise your hand, I think. And so what an antipode is so the antipode of a coordinate is the exact opposite location on Earth. So in other words, if we go to the Space Needle and we start going down and down to the core, we will come out somewhere else. And the coordinates of where we come out is the antipode. Now, it's a myth that the US and China are antipodes to each other. I'm trying to remember where, growing up, we would hear that you dig a hole and you would end up in China. Maybe that was like a Bugs Bunny cartoon or something, right? But the US and China are not antipodes from each other. In fact, and I'll write this in the file, and I'm going to show you where these files are here in a moment, so you can copy them to your environment and play with them. But you can do some research on this. Essentially, only about 3 to 4% of the landmass on Earth has antipode coordinates that are also landmass. Okay, so that's because so much of the Earth is covered in water, right? And there's literally, if I remember from what I read, there's like one spot in the continental United States that has a landmass antipode, and it's some island somewhere. I should have found that one because that one would be kind of fun. But the example I found is not that. So we're gonna play with this a little bit, and we'll demonstrate it on the map as well. So we can declare a function of a struct type to return that struct type, just like any other data type. Okay. So let me explain how we calculate the antipode. To calculate the antipode, the latitude simply changes sign. That one's easy. Okay, so we're going to say chord dot latitude equals negative chord dot latitude. Okay, if I'm 47 degrees north in the Seattle metro area and I go to the and I take the same distance straight south across the equator and take that same distance south, I'll be negative 47 degrees latitude. That's pretty straightforward. To calculate the latitude simply changes, I can't write, simply changes sign. The longitude changes to its supplementary angle and changes sign. Okay, and this is a little bit trickier to do in the math, but let's visualize what that is, right? If I'm 30 degrees west of my center point, I don't just go to 30 degrees east of the other axis. I end up going, instead of 30 degrees, it's 180 minus 30. So that's why it's called the supplementary angle. Okay, and so we'll go ahead and do that by saying chord, let's see, first we're going to check and see, we're going to capture our value, right? And we're going to say if chord dot longitude is less than 0, then our sign is negative 1. I initialize my sign to 1, so I don't need to do the if else here. I just change it if it's negative. Now I say chord longitude equals 180 minus the longitude. There's me calculating my supplementary angle, and I take the sign out of the equation here. So like my 30 goes to 150, or my negative 30, sorry, my 30 goes to negative 150, or my negative 30 goes to 150. That's the argument there. And then I do that by multiplying our longitude by that sign value, right? So a positive longitude gets multiplied by negative 1, and a negative, or sorry, a negative longitude gets multiplied. I think I might have this backwards. Yes, I think so. We're going to test this obviously and see. Okay, and then return the coordinate. And I think that should be good. So now what we're going to do is we're going to so we're going to set a new coordinate of Hilo, Hawaii. I have that written down in my notepad here to the right. 19 .7216 negative 155.0849. Okay, so we have not used, we haven't used our find antipode yet. I have an extra double or extra closer there. And I'm missing a semicolon there. so let's paste this into Google Maps. And if we zoom out, you see we're in Hilo, Hawaii. Kind of northeast side of the Big Island. It's kind of, I think it's the biggest city in the on that island here. And so we're going to calculate the antipode of this. We're going to go straight through the core of the Earth and see where we end up in the other side. Okay, so we do that by we'll declare a new variable, and we'll set that equal to the find antipode of coordinates 2, and then we'll display coordinates. And then for good measure, what we're going to do is we're going to declare one more. And we could reuse one of these if we want, but this way we're just showing you the full sequence here. We're going to find the antipode of the antipode we just calculated. And if you're thinking, well, what does that do? It doesn't do anything, right? If I start with the coordinates, I find its antipode, then I find my antipode, I get back to where I started, right? So that's what's going to be one of our ways we're going to check to see if this worked. Okay, so we went from 1972.16 negative 155.085 to negative 1972.16 24.9151. And then when we went back, we got back to the same location. So that's a good sign. So now we're going to paste this into Google Maps. And you could see we're in Botswana here. And if I zoom out, we are close to a national park. There it is, right? So some national reserve, I think, is what this is. That's exactly opposite from Hilo there. Okay, so there's the demonstration of a basic struct. One thing that I didn't show you in this struct is that I just happen to have my two variables. They happen to be both the same data type. They don't have to be. Like if I wanted to add another coordinate, or if I wanted to add another data piece to my coordinate, I don't know what that might be. Maybe it's an altitude number or a time zone. That might be good, right? I could create an int variable, which is my time zone for that coordinate. And then I'd be able to calculate time zone differences between coordinates, for example. That would have been cool to add, right? So something you can think about if you want to add that yourself, you could do that. The point here is that this struct is as freeform as you want it to be. And it just so happened in my example, I used two doubles. Okay, so there's your basics on struct. We have covered 13.1 and 13.2. Okay, and so only part of the module. I'm going to stop the video here, and I would recommend that you walk through this material if you haven't already. The next video that I'm going to show you will cover the rest of this week's module and next week's module. It's to me a better transition point. The last thing I want to show you, when you're in Linux, you could always type either CD by itself or CD and a tilde to go to your home directory. My home directory is /home/inst/jabramso. And the instructors, that's where we live, right? So if for example, if we just do and we look at this, you'll see here's all the instructors, and you'll see some of us have kind of this is what I call the more traditional Linux username, right? So Professor Black and I, right? We both have just our first name, and all are part of our last name, right? But you can see Professor Iyer and Professor Nick and so on, they have their full name, much like most of you. I can't explain why that is, and my account's been around for a while, and so, but that's just what it is. And so if you want to access something from my directory, if you're in your own directory, right, you could always do slash, you can copy from slash home inst jabramso, and you go to CS161B public, you can copy files from there. And I'll show you what's in there. Right now, I got my file IO that I had demoed last time, a C string example. I think that was in the FileZilla or the PuTTY video, and then the GPS code, which is either this exactly the same or slightly different, right? And in fact, let's just make it. So you can see these are the files that are available to you. If I go back one directory, you'll see that you have write access and you have execute access. You can run my programs that are in there that are already compiled if you want to. The rest of my folders you don't have access to. I just turned all that off so that people wouldn't get lost here. If we look at the home directory, you'll see there's an inst directory and there's a student directory. This is a current snapshot of everybody here. And so you're going to be listed here. I didn't get permission from any of the students to do this ahead of time. I could go into one of the directories, but it looks like you can see the majority of these are shut off. And here's an instructor that, or here's a student that has opened up their directory. And it's up to you to do that. I'd be a little careful because your fellow classmates could accidentally delete your stuff and that wouldn't be good, right? But if you're in one of these directories, again, let's pretend you're in home student, homer.simpson. Again, you can do cp and you can do /home/inst, and you can always hit the tab to autocomplete. See, as soon as if I hit J and I hit tab, it doesn't work, but if you hit tab twice, it shows you all of us that are J's. Oh, look, Professor Black's got 2. Should ask him about that. And then you do an A, and then you do the autofill and fill the rest of mine out. And if you do C, it stops, right? And then you go, oh, CS161B, and you can also that's how you can kind of do some auto, if you will, some autocomplete here. Okay, so this code is available for you to copy and do what you will with it. And look forward to the next video here shortly on the rest of this module. And we'll talk soon.